Yeah, hello, and welcome to the session about CAP and the SAP HANA Cloud Vector Engine. I will walk you through a couple of introduction slides before I hand over to my dear colleague who will show you a demo application and walk you through some code. I'm pretty sure that all of you have seen great applications that leverage large language models recently, be it to generate natural language text or generate code, or to compare documents, be it CVs and job postings. Maybe as a very prominent example of those large language models powered applications, there is that answer questions or Q&A or talk to your document kind of application pattern, where you essentially allow a user to pose natural language questions to some natural language text, and the large language model will generate an answer. In a very, very simplistic way, of course, you can pose your question directly to a large language model like GPT. For example, asking GPT, since when does SAP HANA Cloud support a vector data type? And you get an answer from an LLM stating that it's supported since 2015, which sounds nice, but is wrong. And here is the problem with the pure simplistic approach. These large language models have been trained on public historic data. And of course, they do not know your company internal information or information that has just become public recently. We are supporting a vector data type in SAP HANA Cloud since the first quarter of this year. So there is no way that GPT knows about that. So how can you overcome the large language model to produce wrong answer, to hallucinate? And one very simplistic trick is to provide context. So you give it some information at hand. For example, since the first quarter, we are supporting real vector data type in SAP HANA Cloud, and then you ask it a question. And of course, this time the answer is much better. This approach, providing context to a large language model in order to generate higher quality answer, is usually called RAG, Retrieval Augmented Generation. And that pattern is very simple. You take a question from the end user, since when does HANA Cloud support this and that, and then you search for specific context that you then hand over to a large language model in order to produce these nice answers. So now the question, of course, is how can you create such a content retrieval, such a search system that will give you relevant context to an end user query? And one of the very effective approaches for that is leveraging text embeddings. There are text embedding functions out there that help you to transform natural language text into high-dimensional vectors. And the magic of this embedding function is that text that is semantically similar is mapped to vectors that are close to each other. We see it here in a very simple way on the right-hand side, where we encoded database, table, and icebreaker for data. Run a semantic search, a similarity search, giving as an input a better answer. And with that, over to Wenzel.
So here now we have such a RAG application, and here we have such a RAG application, and the scenario is a movie database. So I can ask my question, for example, how do the plots of the two Super Mario Bros. Movies differ. And we might remember the one was released 2023, the second one. So the historic data which trained our LLM, in this case we use GPT 3.5, it cannot know about the data, especially not the plot of the data. So we get an answer. It talks about the 93 movie. I've seen it as a kid, I've seen it once, that's enough. But here, on the other hand, the 2022 film, so maybe there was a movie announcement, so it's called the animated movie, it's upcoming, and there's no specific plot details known yet. But we are 24. The movie was released. I watched it in cinema, really enjoyed it. So let's press this RAG button and ask the question again and say the magic words abracadabra, and wait for the result. Maybe I was not strong enough now, the whole one. Everyone, abracadabra.
Abracadabra.
Thank you very much. We hear here, and again it mentions the old movie, but there is it says about the second movie. It mentions that, for example, there's Mario and Luigi. It's in Mushroom Kingdom. They even meet the Kong somewhere. That I think it was mentioned. Oh, it's not mentioned this time, but it's talking about this movie, about the newer movie. It knows about it. And let me tell you a secret. I am no magician. I'm an engineer. And this gives you some advantages. Number one, this is pure engineering, so you can do it as well. And number two is magicians let you never look you behind the curtain, but I do. So let's look behind the curtain. What we see now is the prompt. You don't read it, it's a lot of text, yeah? But it's the prompt we send to the large language model, and here's the actual question. How do the plots of the two Super Mario Bros. Movies differ? And we gave additional context, like a movie title, plot detail. But here we get the plot. And as Markus mentioned, we used SAP AI Core to generate an embedding, a vector, a sequence of numbers, and stored these in HANA with the HANA vector engine. And this allows us to search. So our actual process, we can see on the right, is when we activated that RAG button, we added two additional steps. First one is we transform this text into an embedding using AI Core. So we can see this usually takes about a second. It's a little bit slow today, but we have now the embedding, and now we can look up for the 5 most similar movies, which is very fast. So it's 30 milliseconds. That's even slow. Usually I have 20. So that's much faster. We can immediately fastly look up the data out of 10,000 movies and find the 5 best fitting movies. And then we put them into the prompt. We can even switch the view into this expert view, which allows us to specifically search. So as I mentioned, we have plot in our database and the respective vectors. So if I click, for example, a young girl suddenly ages and becomes 30. Maybe you might remember there was a movie from 2004, 30 über Nacht in German. It's called 13 going on 30. We have our plot information here, and we have a similarity of 083, which is really good number. Yeah, so we have really matched that. We have a really good match. And this short sentence summarizes this long text. And it's even better because the words young girl, they don't appear in this text. We have the nerdy Jenna Wink, for example, but we don't have young girl. We don't have the word ages in this text, nor have we 30. We have 30 as a number. Oops. We have 30 as a number here, but not as a written word. So we got the semantics or the meaning represented as a vector, but we don't have the words. So the wording and the semantic, they don't matter that much in that kind of search. And we can even get one step further and switch to the German version, which is ein junges Mädchen altert plötzlich und wird 30. It's the literal translation of that. The Germans can confirm, and we have a lesser score. It's a different language, but it's still number one. And this is how we picked these 5 fitting movies. And if you wonder, how can I build such an application? We can switch our scenario and go to the CAP documentation. So we use GPT-4 this time. It's better with code. And I ask it the question, create an example for Node.js using SAP CAP, which makes use of SAP HANA Vector Engine. Example shall be a movie database where each movie has a title, a plot, and a vector processing the plot, representing the plot. Sorry. Now we let it create itself, and what we did, we took the latest CAP documentation, split it into chunks, and for each chunk we created a vector embedding, stored it in HANA database, and find the respective chunks, and now it is able to create. And we are waiting. Maybe let's say abracadabra again.
It works.
Ah, okay. Thank you very much. Thank you. You're great audience. So we have a CDS definition. We see that it used the new vector type. So we use the adder engine, the adder text embedding engine, which has this 1536 numbers, and we have this cosine similarity, which is this new capability of the vector engine to search for that. And I know it's CAP. CAP is not just Node.js. We can actually do the same thing with Java. I did this in advance, and click on more, and there we get the example for Java. So, thank you very much. Okay. Okay, so some short code snippets. It's the CDS definition of the service. If we want to define an entity or OData, we need to exclude the embedding column because vectors is not part of the OData standard. There's a link to the documentation, so in case you want to follow that. In SQL, for querying something with cosine similarity, so this is a very simple example. If we have a vector, we put it into this cosine similarity function, embedding, so the column is called embedding, and we use the two-wheel vector. This takes the string with its JSON stringified array of values, and then we get the similarities, which are values technically between -1 and 1, but usually they are positive, depending on the embedding model. In Node.js or JavaScript, it looks this way. We wrap this function into this reference object and select from movies with this model. And in Java, we also have this cosine similarity function. To get an embedding for AI core, we have connected it as a destination. It's a simple HTTP request or REST request, and it's a post. We need a deployment ID, an AI resource group, and of course the payload, which is our question in this case. And the deployment ID we can get from the endpoint deployments or LM deployments using AI core, or we just know it by configuration, and the same with the resource group ID. It's a simple request. I think the technical details you get from the example. And if we want to store it, It's a simple insert function. Again, we use the two-wheel vector, which is the way how to do it in SQL. Then we have these entries or these inters with entries, and here we just use the string. To wheel vector is called implicitly, and it's similar for Java as well. Thank you very much, and back to you, Markus.
Yeah, what we've seen is the power of text embeddings and how to use semantic search in such RAG-based patterns for Gen AI applications. The approach we leverage for that application is quite simple, and using text embeddings and using a vector database is just one approach, however, the most prominent these days. But there are also alternatives. I mean, if your data happens to be in a relational database in tables, you can also retrieve these database records in order to provide some context. And common approaches are text to SQL conversion in order to retrieve database records. On the other hand side, most of you have built full text search applications, which you can also plug into such an architecture using keyword or sometimes called sparse retrieval techniques. Last but not least, some approaches also leverage knowledge graphs, so RDF graphs and Sparkle as a query language in order to retrieve a little bit structured context for such a RAG application. The nice thing about this, all of these capabilities are supported in SAP HANA Cloud, so depending on your data and your retrieval techniques that are already available, can be leveraged in such an architecture. However, I have to say, knowledge graphs is currently in the making. So if you watch Sapphire currently going on, you will see some announcements for support for knowledge graphs in SAP HANA Cloud coming up. Now, one technique I also would like to pitch very quickly. We have seen movies and the CAP documentation. So what if you have a Q&A application that lets the user tap into one or the other? So how do you decide actually which vector database or which table do you use to pull the context? And for these type of decisions, frameworks like LangChain, for example, offer possibilities to create an agent, which is nothing more than prompt to a large language model and ask a large language model, hey, based on the user input, please decide which table, which vector store to use. Where is the most appropriate context store? So this is agent-based retrieval. This is a technique if you need to decide which data to draw into a context. And last but not least, what we've seen is plain vanilla, simple RAG, where you just pose the question and get some context. There are more advanced techniques out there, for example, self-reflection or autocorrelation, where you essentially retrieve the context in the first step, but then hand these retrieved context over to a large language model and ask it, hey, please assess these documents. Are they useful? Are they related to the question? Can I answer the question based on that document? And based on the decision, if these documents are not useful, you can decide to rewrite the query and retry the context gathering. If the context is great, it's good, it's useful, you can generate an answer or ask the LLM to generate an answer. And then again, you can self-reflect. You can pose the answer together with the question again to the LLM and ask it, hey, please assess if the provided answer really answers the questions. And depending on the assessment of the large language model, you can generate the answer or add another loop to all of that. This is just to give you an idea what's currently going on with regards to the RAG pattern and its extensions. And that's all we have. We're around here for questions. Thanks for your time.